This is the second part of the Saxon Advanced Math lesson 46B, and that's factoring over complex numbers. Now, this is going to look very similar to what we just accomplished in 46.A because I did a little bit of it ahead of time just to prep you for this. So if I looked at what I have here, if I had 2x squared plus 6 equals 0, and I factored a 2 out of both terms, I end up with pulling the 2 out the front, and 2 divided by 2 is 1, and 6 divided by 2 is 3, and so I have x squared plus 3 multiplied by 2 equals 0. If I divided both sides by 2, I'd end up with x squared plus 3. Move the 3 to the right, that gives me x squared equals negative 3. At this point, if I took the square root of negative 3, that gives me x is plus or minus the root of negative 3. Remember that a root of a negative number can be written as the root of the positive version with the I on it. And therefore I could say x is going to be equal to x minus the root of 3, which is 3i, and x plus the root of 3i. This would give us the factors of this. And this is factoring over the complex number set. It gets a little more exciting though when we start looking at like 46.2, and they're giving me this factor, this quadratic equation, and I'm looking at it saying, how am I going to factor this? Well, I'm going to do very similar to what I did up here, just pull the 2 out first. Remember to always pull out any highest common number you can out of all the terms. Get that out to the front right away. It doesn't get canceled. We are going to hang on to it a little bit later, but for right now, we're just going to pull that out to the front. That makes that x squared plus 2x plus 4. Now, if I factor this, I have multiple ways I can factor. The easiest one is going to be using my quadratic formula, although you can complete the square on this, and it does work. It's a lot more effort to do so. So if we remember what our quadratic formula is, negative b plus or minus the root of b squared minus 4ac all over 2a, and I went ahead and labeled a, b, and c, and then put them in here. When I do so, and you can see as I follow this, if you need a little bit of help with this, look at 46.A again, as I went through that in detail in that lesson. This gets me down to x equals negative 1 plus or minus the root of 3i once I've simplified. That gives me 2 roots. This is a root, negative 1 plus the root of 3i, and negative 1 minus the root of 3i. This is where we're going to use the same method we did in 46.1, which was I'm going to go ahead and put that into the x minus, because these are roots, but I didn't want the roots. I wanted the factor it over the complex numbers. I wanted to factor it. I don't want the roots. This, and the quadratic formula does really well on giving me answers. This is what x is. That's wonderful, but that's what the root of the answer is. I don't want the root. They didn't say solve for x. They said factor. So I need to go back to whatever that would be to get those roots. So I'm going to plug these in to x minus and x minus. I put the word coefficient here because this number is going to show up back here again. This is where I'm putting it back in. It never really went away, but I'm remembering that I pulled the 2 out to the front, so I'm putting the 2 back in here. My first root goes in the first blank. My second root goes in the second blank. When I do so, that's going to give me x minus a negative 1 plus root 3i, and x minus a negative 1 minus root 3i. Don't get confused that these two would be the same. This one has a plus, and this one has a negative. That came from my plus or minus right here. Once I do so, I drop the parentheses. In order to drop the parentheses here, I'm going to say a negative makes it a positive. A negative times a positive is a negative. On here, a negative times a negative is a positive, and a negative times a negative is a positive. So the only thing that really changed is these two signs. So be very careful with those. This is my answer because this is the factored version of my original right here. If I were to take the time and multiply this back out and cancel all the complex numbers that can, whether that be from squaring them or canceling them because I'm adding and subtracting the same value of I, when I do so, I would get this term again like I was looking for. So this is a factoring method, and I think it's easy for students to look at these and say, well, weren't we already doing this? Weren't we already coming up with answers? Yeah, we were taking this and finding the roots. That's where we started before. We found the complex roots. We understood that the root of a negative value is I. And so we would get to this point here and we would say, yes, there was my answer. This is very similar to that. We're just taking it one step further and we're saying, well, if these are the roots, what was the factored form that would give me those roots? And so I'm plugging it back in as if I was going backwards just a little bit into the problem and saying, okay, what times it's another number with a coefficient out front would give me these this quadratic equation. And that's how I'm going to factor over the complex numbers. Now, the thing is it's not nothing special as far as they're really just giving you this number and saying factoring. The fact that they're telling you it's over complex numbers is just them identifying it, so in your head you think, oh, wait a minute, this may not be as easy as just factoring. I'm going to have some different method than I've had before, because we've always factored on numbers that either worked really well or they've said, don't factor it, just find the roots. And now we're going back with the roots and finding the factors.